Dear students, you are welcome in this class. I am Dr. Dinesh Kumar, Principal Scientist in the Division of Agronomy. Today we are going to discuss problems of supply and availability of nutrients. So here the main point is problems of supply. Problems of supply is with respect to nutrients, plant nutrients. Means there must be some problem in supply of the nutrients. But where? Here the main answer is that supply of nutrients to the soil solution. Because nutrients in soil solution are in available form, and as you know that they are taken up by plants. So it is mainly problem of supply of nutrients into the soil solution. If our soil solution has sufficient supply of the nutrients, then plants can easily take up. I think you would agree to this statement that we need most of the nutrients in soil solution so that plant can take up them in them easily. This is the point. Now question comes, what is soil solution? If anybody knows, kindly tell me what is soil solution. Anyone? Come forward. What do we mean by soil solution? Anybody? Sanjeev Meena, video kholo. Khushbu, do you know what is soil solution? Hello? If you are not there, should I stop this class? Anik? Are you there or
Yes,
not?
sir.
Yes,
sir. Yes, sir.
If you are not interested, I'm also not interested. I can stop it here. Okay? If you are interested, then only I can continue teaching. If you do not know, tell me we don't know, sir. That will be fine. But please do not keep your quiet. So, Anik, do you know what
No,
is?
sir.
Okay. Anybody else? Ayushi?
Sir, in which all the nutrients are in available.
Okay, I think you have fair idea, but your voice is breaking, so we are not able to listen what you are saying.
So there is a network problem in Falguni hostel. So
All right, you are not audible, still not audible, Ayushi. Anyway, Rakshit, can you try?
Sir, it is an solution present in the soil which may contain nutrient salts or mineral salts.
Yeah, that is so simple. So what he said, he replied very rightly, very correctly, that it is a solution of water with molecules, ions, minerals, certain minerals, nutrients, etc., etc. So it is kind of, you can say, blood of soil, which has all kind of minerals, nutrients, and that can be supplied to plants. In our case, blood can supply these nutrients or materials to different body parts, our different body parts. It gets circulated. So same way, you have got soil solution where the nutrients are dissolved in water, and then only they are in available form. And whatever nutrients are present on the exchangeable sites or on the soil colloids, most of them have to come into the soil solution to make a supply, because supply of nutrients will be depleted. Because from soil solution, three kind of losses of nutrients can occur. What are those? How the nutrients will be lost from the soil solution? Anybody?
Through volatilization.
One is by?
So through volatilization.
Exactly.
Volatilization.
Yeah,
Leaching.
leaching. Very good. And because they are in available form, they can be taken up by plant Of course, plant uptake is good for the plant, but anyways, you will lose the nutrients. Means there will be short supply of nutrients from the soil solution, isn't it? And also certain microbes, microbial activity, they will also require certain nutrients for their growth. So microbes can also take up nutrients from soil solution, but they can also give it back. If your nutrients are lost by leaching, they may not come back to the soil solution. But if the nutrients are taken up by your microbes, then they can be returned back when these microbes decompose. And also nutrient losses can happen due to volatilization. So what are the nutrients that are lost by volatilization? Anybody? What are the
Nitrogen.
nitrogen? Is it only nitrogen, or do you think there may be some more nutrients that can be lost by volatilization? Or you can say gaseous losses. Any other idea? Can you go beyond?
Sulfur.
Huh?
Sulfur.
Yes, it is sulfur. So next is sulfur. Sulfur is partly lost in gaseous form. You know, under anaerobic condition, it can be lost as hydrogen sulfide. And under aerobic conditions, there may be volatilization of sulfur in the form of
SO2.
SO2, correct. So why do you fear? It is sulfur dioxide, because under oxidized condition, sulfur will make sulfur dioxide. So these nutrients in soil solution can have a different mechanism for their use or for their losses, leaching, volatilization, your plant uptake, and microbial use. And also you can see some of the available nutrients in solution can go back to the colloids. They can also go back into the colloids because they are in equilibrium. You know, they are in equilibrium with inorganic colloids. They are in equilibrium with organic colloids. And these inorganic colloids are in equilibrium with mineral also. Because if there is shortage of these ions in the exchangeable sites, then certain minerals can break down and they can resupply. So this is a bit complex process, but we'll try to make it simplify. And today you will learn cycling of nutrients in the soil and then discuss the factor influencing supply of mineral nutrients into the soil solution. So what are the factors that will affect the nutrient supply to the soil solution? Nutrient supply to the soil solution means it will be availability of nutrients to the plant. Indirectly, you can call it availability of nutrients to the plant. So we need to see all these factors that will affect the supply of mineral nutrients to the plant. Do you have any idea that what factors are important in supplying the nutrients to the soil solution? What factors can affect? pH, yes, soil pH is important. Then there are so many properties of the soil.
Availability.
Huh? Yes.
Moisture of the soil.
Moisture, yes. Soil moisture is a physical factor. So you can think of different properties of the soil. You know, physical properties. So what are the physical properties? Your water content, one. Second, soil structure, soil texture. They can affect the nutrient availability. Coming to your chemical properties, you have said soil pH is a factor that can affect nutrient availability. What could be the next? Please come.
Microflora and fauna of the soil.
Okay. Means activity of microbes or microbial activity is main. Of course, macroorganisms or mesoorganisms are also important. But here at micro level, at solution level, these microbial activities are rather more important. So you are right, microbial activities are important. How about cation exchange capacity and anion exchange capacity? Do you see any role of these kind of chemical property? You know, cation exchange capacity and anion exchange capacity is a chemical property of the soil. So can it influence the nutrient availability? Anybody?
Yes, sir.
डर क्यों रहे हो तुम लोग? Why do you have fear? Just throw some ideas. So cation exchange capacity and anion exchange capacity, they are going to affect the nutrient supply, soil texture, organic matter, microbes, all these water content, all these will, and also the buffering capacity. Buffering capacity, do you know what is buffering capacity of the soil? Anybody? Anybody from soil science? Anik? What is buffering capacity of soil? Anyone?
So it is a soil's ability to maintain its pH in a stable form.
Correct. Means if you make a disturbance in a soil, particularly in soil pH, it resists this change. It resists this change. So therefore, this is a kind of buffering capacity of the soil. It is response of the soil to kind of some disturbance. Particularly if you wish to make a change in soil pH, it is not easily changed. That kind of property is your buffering capacity of the soil. Actually, here in the subject of soil solution, you can just remember that buffering capacity is with respect to resupply of nutrients into the soil solution. Suppose in soil solution, certain nutrients are there, and as you know, they can be lost by leaching, they can be used by microbes or plants, they can be volatilized. So there are several mechanisms by which these nutrients are used from soil solution. And then there will be deficit of these nutrients or elements in the soil solution. And now these should be resupplied from the colloids. This can be resupplied from the microbial activity. They can be resupplied from the decomposition of organic matter. So there can be 3-4 sources in the soil to supply nutrients to the soil solution, isn't it? So it is the capacity of the soil to supply nutrients to the solution or resupply nutrients to the soil solution, which is also a kind of buffering capacity with respect to resupply of nutrients. It should be clear, I think, by now. Next is your base saturation, percentage base saturation. What is percentage base saturation? Or I ask a straight question from Shambhavi. What is cation exchange capacity? If you know, say yes. If you do not know, say, sir, I don't know.
So it is the soil's ability to hold the positively charged ions in the soil.
On the, right, fine. She's saying that cation exchange capacity is the amount of negative charge or capacity of soil to absorb positively charged ions. So actually cation exchange capacity is a negative property. Overall, it has negative charge. So how many total negative charges are there? That is your cation exchange capacity or capacity of soil to hold cations, or capacity of 1 kg of soil to hold a certain amount of cations. That is your cation exchange capacity. Similarly, you can also define anion exchange capacity. So anion exchange capacity is with respect to positive charges. How many total positive charges are there on the colloids? That is your anion exchange capacity, or capacity of 100 gram soil to absorb anions. What quantity of anions can be absorbed by a fixed volume or fixed quantity of soil? that is anion capacity of the soil. Now, I hope that you are clear about cation and anion exchange capacity. Now, question comes, what is base saturation? And why this base saturation is important? You know, cation exchange capacity is important to resupply nutrients. Higher the cation exchange capacity or higher the anion exchange capacity, higher will be resupply of nutrients or ions into the soil solution. So how come this base saturation is important in that? First, you define base saturation. Hello? Anybody? Aman?
Yes,
What
sir.
is base saturation? Percentage base saturation.
Sir, in whole cation exchange capacity amount of bases like calcium, magnesium, potassium.
Not
In
sodium?
percentage of this in total, percent of this in total cation exchange capacity.
You are correct. Absolutely correct. But you can just add sodium more. So it is
Yes, sir,
calcium.
calcium, magnesium.
But so why were you keeping silent? You knew the answer, but still you were not answering. Please try to interact. Okay.
Yes.
I'm not
Yes.
punishing you. It is just kind of discussion, interaction, learning from each other. And I'm seeking your attention also. Therefore, I'm asking questions. So nobody is sleeping, at least those who are present online. So now you know this base saturation is also important because certain bases like this aluminum is also a base, but it is excluded from here. We'll discuss all these points in detail. This was just introductory part, and now you can see some terminology. Same kind of terminology you can see. Adsorption, you understand, when it is taking up or uptake of molecules. Remember, adsorption is with respect to molecules also, or ions on a surface, including exchangeable cations and anions on soil colloids. This is how we define adsorption. Base saturation is fraction of total exchangeable cation or part of the cation exchange capacity, you can say, that are occupied by bases or basic cations like calcium, magnesium, potassium, and sodium. Is aluminum a basic base cation? It is not. If it is base cation, it could have been here. But this aluminum will go to cation exchange capacity. Now, buffering capacity of the soil. Ability of soil to resist change in concentration or activity of its constituents and its properties in response to external intervention. If you have any external intervention or any disturbance of the soil, it tries to resist that change. This property is buffering capacity, but most of the time it is referred in respect to soil pH. But there could be some other soil properties also that can be defined in terms of buffering capacity. One more thing is there, which is amphoteric. Soils are considered as amphoteric in nature. What do you know about amphoteric? A-M-P-H-O-T-E-R-I-C, amphoteric. Soils are amphoteric in nature. Any soil scientist? If you do not know, please write it on your notebook and try to learn it. This property, amphoteric in nature, means if the need be, soil can act as a base. If need be, they can act as acid material. So you can know more about amphoteric property of the soil. Now, diffusion, you already know what is diffusion. Now, ion, already discussed what is an ion. Ion can be atoms, groups of atoms like nitrate, nitrogen, and oxygen, or compounds which are electrically charged, loss or gain of electrons. Then you call it charged particles or are your ions. Nutrient mobility. Mobility, this is with respect to soil, not with respect to plant. So here ease with which nutrients move from one place to another place in soil. How fast they can move, how slow they can move. This is called as mobility of the nutrients. So what nutrients are mobile in soil and what are not? Any idea, Lokesh? Lokesh, are you there? Mr. Lokesh,
Yes, sir.
if you are there, open your video and answer this question. हेलो, अरे नहीं आता तो मना कर दे यार, क्यों
Yes, sir.
जानता तो बता दे. बताओ, which nutrient is mobile in soil, which is immobile? Any other student?
Sir, NPK is mobile or calcium and sulfur is little in.
Okay, at least you made an attempt, though may not be fully correct, no problem. So your nitrogen is mobile, sulfur is mobile, and your phosphorus and potassium is less mobile, or phosphorus particularly is considered as immobile. So mostly these micronutrients like your zinc, iron, manganese, copper, they are immobile in soil, and negatively charged particles, negatively charged ions, except phosphorus, like your nitrate, sulfate, they are mobile in the soil. So, and positively charged, they are less mobile in soil. And this phosphate ions or micronutrients ion, they are almost immobile in soil. Is it fine? Now you tell me this, can we have leaching of ammonium nitrogen from the soil? Because nitrate nitrogen is leached down. So can we expect leaching of ammonium nitrogen also? Leaching of potassium also? Can we have? Yes or no?
Yes, sir.
Yes. Many times students think that nitrogen leaching means only nitrates are lost. But in this case, nitrogen leaching, ammonium can also leach down, particularly in soils which have low cation exchange capacity. Suppose you have applied nitrogenous fertilizer and you have mixed it into the soil, there will be ammonium formation. And if your soil is having very low cation exchange capacity, then under these conditions, ammonium can also leach down. Potassium can also leach down. And leaching can occur in case of phosphorus also. But phosphorus is leached down mainly from the soil solution. Mainly from the soil solution. Another question is that between phosphorus and potassium, which one is more mobile and which one is less mobile? Between phosphorus and potassium.
Potassium is more mobile.
Correct. Now we go to soil solution. Now see soil solution. The liquid phase, as it was told in the beginning by Mr. Goda, the liquid phase of the soil which contains dissolved nutrients in plant available form. So here in this definition, you are restricting only to the dissolved nutrients, but it may also include other molecules, other molecular forms of solutes. Some other solutes can also be there in this soil solution. Available nutrient means portion of any element or compounds in soil that can be readily absorbed and assimilated by growing plants. This is how to define available nutrient. Crumb structure, you understand. Exchangeable ions are mostly positively or negatively charged atoms. They are groups held on surface of a solid. I think you know what are the exchangeable ions. Means cation and anions that are adsorbed on the clays or organic colloids or humus are your exchangeable ions. How to define heavy metal? So they have densities of 5. Remember, the densities are very high. That is why they are called as heavy metals. Heavy metals, and in this, the density is about 5 tons per cubic meter. or more than equal to or more than 5 tons per cubic meter or gram per cubic centimeter. Any metal which is having such density is called as heavy metal. And also generally they have more than 23 as atomic number. Examples are cadmium, cobalt, chromium, copper, iron, mercury, manganese, molybdenum, lead, and zinc. You can see copper is there, iron is there, and Mn is there, zinc is there. So we mainly deal with these nutrients as essential nutrients. However, if we see them from the angle of heavy metal, then they are also considered as heavy metal. So therefore, it can be concluded that all the heavy metals are not that much harmful as certain heavy metals like cadmium, chromium. They are more harmful to human health, but iron, manganese, zinc, etc., they are useful also. So now one more term is there, isomorphous substitution. Means replacement of one atom by another atom or replacement of one ion by another ion. They have similar radius. So this is your isomorphous substitution. Trace elements present in earth crust in concentration less than 1000 milligram per kg. So such kind of elements are called as trace elements. Now, for whatever I am teaching in this lecture, you need to study same from chapter number 2 in Howling book, the Soil Fertility and Fertilizers. This book is available with you, and it is suggested that each one of you should read chapter 2 of this book. This is one of the best chapters on this subject. Every line is very, very important in this chapter, so it is up to you whether you like to read it or not. But I have drawn most of the part in this lecture from this book, plus nature and properties of soil. So now let us see in detail, what do we mean by soil solution? So there are a number of definitions of soil solution. So here before you, you can see how to define it. So it is a medium for plant nutrients. First important thing, that it is a medium for plant nutrients where nutrients are released from the soil solids into the solution for absorption by plants and microbes. So absorption can happen by plants as well as microbes, because microbes also want nutrients in soluble form. So whatever is dissolved in water in soil solution, that is in soluble form from the perspective of plant nutrients. So next definition, you can see it is water surrounding the soil particles. Water surrounding the or in the vicinity of soil particles, whatever water is there, that is your soil solution. Or you can say a liquid phase that contains dissolved ions, gases, and other water-soluble compounds. So this is your soil solution. Another definition, you can see the liquid phase of soil, which consists of dissolved substances, both organic and inorganic, in ionic or in molecular form. So you can see the last one is completely defining soil solution. Liquid phase, which consists of dissolved substances, all kind of dissolved substances, because you know certain amino acids, certain organic acids. So thank you very much. Welcome back. And as you know, I have given you 3 links. First link was for a start, and second link in between, and then finally this second link, we lose second link around 6:15. Then please join by third link. It is just to record the presentation. So therefore, I'm using 3 different links, and everything will be over by 6:40 or 6:30. Okay. And we continue, and I hope you understand what is soil solution. We try to understand more about soil solution. It transports chemical species to and from the soil particles, because solid particles will also give us nutrients into the soil solution. It provides intimate contact between the solutes and soil particles. Its pH influences the solubility and in turn the availability of several nutrients to the plants. The pH of the soil solution is very, very important, particularly for the solubility of or availability of different ions or different nutrients. Volt, 1994, he has given definition of soil solution. And you can see this definition recognizes that at a molecular level, some soil solution is part of it. What is soil solution? Now you see a continuum of phases exhibiting indistinct interfaces at the molecular level. Solutes in the aqueous phase may be associated with bound water at the surfaces of soil colloids, free water percolating through soil macropores, water in the free spaces of plant roots, or immobile water in soil micropores. So now you can see what actually constitute the soil solution, because it is not that it is present in one place. It can be present at several places in the soil. So first place can be solutes in the aqueous phase may be associated with bound water at the surfaces. Some water may be bound at the surfaces of particles or soil colloids. There also you will find soil solution, and there may be some free water percolating through the soil macropores. So this was actually also soil solution, because water must have contained some salts, some solutes, some nutrients. Therefore, even the percolating water, once it was also a soil solution. And then water in the free space of plant roots. In the plant roots, there may be some free spaces. There you will find some water, which may also contain soil solution, or which is also soil solution. Or immobile water in soil micropores, or your capillaries, where you can find some immobile water that is also kind of soil solution. So you can see there are different portions of soil solution in a soil. Now you can see a picture. This picture tries to make you more clear. So you can see the soil solution. This particular circle is your soil solution. And then these soil solids, it is surrounding the solid part of the soil. And you can see this is hydrosphere. Hydrosphere means it is water plus solutes. Now, how to separate soil solution? Now, question comes, particularly in soil science, they are expressing many times nutrients are expressed based upon the soil solution. That soil solution contains so much of zinc. Soil solution contains so much of iron or nitrogen. So we need to study soil solution, and first we need to separate it from the soil. So there are a number of methods to separate the soil solution. The simplest one is that you can use some bigger sampling of the soil in columns. In columns, soil columns can be taken or created, and in lab, soil solution is separated. It is not possible to separate soil solution in the field. So how to separate soil solution from soils? For some soils may contain as little as 10% by weight of water at field capacity. Means it may be very small weight, little as 10% by weight of water. Means at field capacity, you will have different moisture percent. So sometimes you can have 10% water at field capacity. In certain very light texture soils, the water content at field capacity may be very low, can be as low as 10%. If it is 10% water holding capacity, then, or moisture content, then your soil solution proportion will be very small. If this becomes 25%, then you can have more solution, more soil solution. So it depends upon the water retention at field capacity of the soil. Reliable method to displace solution from a column means now how to push or how to remove the water, this soil solution from the soil column. So we can have carefully packed soil, slowly percolate another liquid through it. So in practice, people use alcohol and electrolyte solution. One of them can be used, and you pour it into a soil column, and then this the liquid, the soil solution will go down, and that can be collected on the bottom side. The alternative method is to use air pressure. Instead of alcohol or electrolyte solution, one can use air pressure or suction. Suction can be done on the bottom side and pressure can be put on the head side. So you can extract the soil solution by using air pressure or by using suction method. Our job is not to go into much details of this, but you can have idea that soil solution can be extracted, one by alcohol and other is by pressure or suction methods. And why we are extracting it, we can know the nutrients level, we can know what are the solutes, we can know the concentration of different nutrients in the soil solution. The concentration of soil solution varies between soils, depending on leaching regime, fertilizer addition, crop uptake, and processes that affect mineralization of soil organic matter. So there are number of factors that will affect the concentration of soil solution. Means how much concentrated a soil solution is. So this can be affected, means whether it is diluted, much diluted, or is it much concentrated. So it can be affected by leaching regime. If leaching is fast, leaching is very frequent, then your concentration will be more. So simple to explain. Fertilizer addition, if you are not adding fertilizer to the soil, then concentration will be less. Crop uptake, if crops are such which remove more nutrients, more removal is there, then you will have lower concentration of nutrients in the soil solution. Processes that affect mineralization of soil organic matter. Means if the processes are inhibited, are stopped, then concentration will be less. If you get faster decomposition of organic matter or mineralization, then your the solution will be richer in solutes. And generally, you can see that is why you get range of this cation and anion from 5 to 50 milliequivalent per liter. This is a general range of nutrients in soil solution, ranging from 5 to 50 ppm of cations and anions both. But this is for non-saline soils. In saline soil, this concentration will be more because of higher sodium. So it can go as high as 100 milliequivalents per liter for saline soils. As the milliequivalent is 1000 of the equivalent weight. So this milliequivalent is not milligram. You need to multiply milliequivalents with equivalent weight. Then you can get milligram or concentration in ppm. As the moisture content is reduced, the concentration of soluble salts increases. That means you will get concentrated soil solution. Is it clear to everyone? A few lay. Is it okay?
Yes, sir.
Fine. Now, dear students, you see, this is very interesting data, and you can have several interpretations from this. Relative distribution of nutrients between the common soil nutrient storage pools. It is from Western Sierra Nevada. This is from USA. Whatever country may be there, it does not matter. Now you see to understand that what proportion of total nutrients are there in the soil, in which form. Now you see, for example, calcium. See the column of the calcium and go to the bottom. And now you see primary minerals. So most of the calcium in soil is confined in primary minerals. Sanjay, you can see this. This is so high. You can see it is in kilogram per hectare. 789,000 kilogram per hectare, or 700 kilogram per hectare. It is in primary mineral in this particular soil. And you can see how much calcium is there on exchange or sorption side. 31,900 kilogram calcium is there. And in organic matter, it is 2,337. But despite all these higher concentration or higher content in organic matter, primary mineral, or exchange sites, only 16 kilogram in 1 hectare soil is in soil solution. So you can see very small fraction of total calcium is in soil solution. So that is the basic purpose of showing this data to you. Now you see next for magnesium. Same story, almost same story. You can see very high quantity of magnesium is there in primary minerals in soil. But you see in soil solution, it is only 4.3 kilogram per hectare. Now see potassium. Potassium is only 8 kilogram per hectare in soil solution in 1 hectare area. Now see for nitrogen, very minute quantity of nitrogen. Though nitrogen is removed in largest amounts, mostly by cereal plants compared to other nutrients. But you see the concentration of nitrogen in soil solution is smallest, even less than phosphorus and less than potassium. It is only 0.2 kilogram per hectare in soil solution in this case. But in primary mineral nitrogen is 0. As you might be knowing that nitrogen is not part of any minerals in soil. So you get 0 contribution from minerals, but organic matter is the major pool of nitrogen in soil. In this case, it supplied about 10,700 kilogram total nitrogen per hectare. Now you see what proportion is this in soil solution, 0.2. Now see case of phosphorus, 10,500 kilograms per hectare phosphorus in minerals, and then in organic matter, and finally you see in soil solution, the quantity of nutrients is very small. Hope you could understand something from this slide. Now you see listed in increasing order of plant availability. Soil K exists in 4 forms. Now just showing you the different forms of these sources of nutrients in soil. For example, if it is your potassium. So first, again, you see mineral form is very high, 5,000 to 25,000 ppm in soil, means 0.5 to 2.5% content in soil. It can range 0.5 to 2.5%. It can be the range in soil because it is there in minerals. Many minerals contain potassium in soil. Now see what proportion or concentration is in non-exchangeable form. In non-exchangeable form, it is 50 to 750 ppm, parts per million. If you see exchangeable form, it is from 40 to 600 ppm. And solution, you see only 1 to 10 ppm. What you have seen in the last slide, it is little bit more simplified and quantified here by Havlin. Hope you understand that very small fraction of total potassium is in soil solution. Now see the case of phosphorus similarly. Phosphorus in soil solution is very low, ranging from 0.001 milligram per liter. See very small concentration in soil solution in very infertile soils to about 1 milligram per liter in rich, heavily fertilized soils. So you can see range of phosphorus in soil solution may be from 0.001 ppm to 1 ppm, very small. And similarly for phosphorus, for potassium in soil solution, it can be 1 to 10 ppm. Please note down these 2 values. They are important for your quiz exams. Somewhere you will find them. Now see this, all these 4 figures in this picture, you need to remember. This is for potassium. You can see 90 to 98% potassium, whatever total potassium is there in the soil, 90 to 98% potassium is in primary minerals. And these primary minerals could be feldspar and mica. And if there is shortage of non-exchangeable potassium, or that is fixed in 2:1 clays, this is your non-exchangeable potassium, which is fixed in interlayers. So this is 1 to 10% of the total, 1 to 10%, because on the bottom you see 90 to 98%. And then you see exchangeable potassium is very small fraction, which is 1 to 2% of the total potassium. And solution, it is 0.1 to 2%. So all these 4 values are very, very important. They will definitely come somewhere in your quizzes, in your any other exams. Now, After knowing some basics about the soil solution, what is soil solution and how the nutrients are supplied, what are the sources of nutrient supply to the soil solution, and where it is found in the soil, and what are the concentration of different nutrients in the soil solution. You observe that the concentration of different nutrients was very small for most of the nutrients, and the smallest concentration was seen for nitrogen. You have seen it was smallest for nitrogen, and perhaps in the list highest was for calcium. But maybe the characteristic of that particular soil, it will vary. Now we go for the importance. Why we study it? Why it is important? Because it serves as a source of nutrients to the plant. So finally, plants will take up nutrients. Therefore, it is important. Medium for most chemical and biochemical reaction. So a lot of reactions happen in this part because nutrients get solubilized here. Medium for transport of nutrients and pollutants. Nutrients are transported and pollutants are also transported into the soil solution, and they can leach down also. It controls water availability, and may cause salt injury to plants in certain specific soils where your sodium content is large. It removes toxic substances when it is more diluted. Toxic substances leached out. So sometimes if you have added extra dose of herbicide, many times it happens with the students. They can add excess dose of the herbicide, and that can straightway go to the soil solution and immediately taken up by the crop plants also. So one herbicide which you are applying to control the weeds, if it is applied in excess dose, it can harm your crop also under these conditions. So therefore, the leaching is the only way. So you need to apply water again and again so that this soil solution can be leached down. But at the same time, you will lose some quantity of nutrients also from the soil. So certain cases, you can remove some toxic substances from the soil. Now, it also moderates temperature. Also, because of water present in soil solution, acts as an agent of weathering. It may contain some acids also, which can weather certain minerals. So it can help in the weathering of the minerals present in the soil, particularly its influence through the pH or some water is also there, abrasion. Soluble salts of soil solution control properties of saline soils. Soil solution salt movement controls the genesis of soil, controls the oxidation reduction reactions occurring in soil. So variety of roles are being played by soil solution. Besides supplying the nutrients in available form, number of roles are played by soil solution. Now, dear students, you see, now the main topic revolves around problems of supply and availability of nutrients. So here, problems of supply means problem of supply to the soil solution. Why many times nutrients may be there in the soil, but they are not supplied to the soil solution. So what could be the reasons? Or in some cases, supply of nutrients to the soil solution may be less. So we need to study that. So the presence of sufficient quantities of nutrients in soil does not guarantee the availability of these nutrients to the plant. So therefore, this subject becomes very, very important. So now you see this picture, availability of nutrients to the soil solution, how it is affected. So you see leaching. Soils where you get more leaching, more losses can be there, and hence the availability will be affected, or rather I can say availability will be reduced because of leaching. Similarly, availability can be reduced by plant uptake and of available nutrients from soil. And microbes, perhaps they are missing here, but microbes can also take up the nutrients like plant take up is there. Similarly, microbial uptake is also there. Now, these are the needs, these are the losses, but where from the supply comes? Supply comes from cation exchange capacity or anion exchange capacity. It can come from soil organic matter after decomposition. It can come from primary minerals or minerals which have been fixed, like in case of phosphorus. Your tricalcium phosphate can be broken down under certain conditions if the soil solution phosphorus supply is reduced. So there are cases where this tricalcium phosphate can supply, but it is less soluble. So certain minerals can supply nutrients to the soil solution. Microbes can also supply on their death. Air, air can also supply. Air deposition can be there, and this air, sometimes rainfall can also mix with air, and it can bring down certain nutrients that can go to the soil solution. And not just nutrients, it can bring some more materials also. And when you add fertilizer or manure, they also increase the supply to the soil solution. Now, main problem comes here. Main problem comes in the supply. How to get more supply? By manipulating the cation exchange capacity or anion exchange capacity. Can we manipulate all these? So wherever possible, we can manipulate all these and try to increase the supply. Are you able to see me? Hello? Am I connected to the online Zoom? Shreya? Hello, Aman? There was a break in internet. So, are you able to listen me or not? Hello?
Yes, sir.
Okay.
Yes, sir.
Thank you very much. So now we continue. There was some break in this internet. Now you go to the next slide. Sources of supplying nutrients to the soil solution. So just what I discussed, that has been summarized in this slide so that we get more clarity about this subject. So you see what are the pathways of nutrients in soil solution. Plants take up nutrients mostly from soil solution. Number one statement, everybody knows. It has a small fraction of total nutrient. You have already seen it. Third point is nutrients removed by plant from the soil solution, and thus the pool depleted. There may be shortage of nutrients in the soil solution. They may be lost by leaching also. Then nutrients are readily replenished or resupplied into soil solution by cation exchange. From cation exchange or anion exchange, nutrients can be supplied to the soil solution. Now you see, these are the four important sources of resupplying nutrients to the soil solution. Soil minerals, exchangeable cations or anions, chemical compounds, or organic matter. So chemical compound may be sometimes your fixed form of nutrients. So now you see more clarity what is happening in the Havelin's loop. Source of nutrient supply or mechanism how nutrients are supplied to the soil solution. In the central part, you have soil solution. These nutrients can come from air. And they can also go back to the air. They can come to the soil and they can go back to the air, volatilization, etc. Nutrients are removed by plant uptake. They can come to the soil solution from exchangeable sites or from colloids. Soil colloids, these nutrients can come, and some can come from primary mineral or other fixed form of nutrients can be solubilized and they can come to soil solution. Similarly, rainfall can also add nutrients, and drainage or subsurface drainage or leaching, you can lose nutrients. Organic matter can add nutrients to the soil solution, or microbes can also add and they can also take. So this is how the different pathways of nutrients are happening in the soil solution. Any question, any discussion at this point of time? Anybody has any question? Khushbu? Abdul? अरे जागे हो सोए हो?
No, sir.
हैं? जागे हो? Do you have any clarification, any point, any question? राघवेंद्र कैंटीन में बैठे हो या हॉस्टल में हो, ये बताओ।
लाइब्रेरी में सर।
लाइब्रेरी में हो?
हाँ
ओके
सर।
ओके। हैं? यार इसे भिड़ा दे दो और शिवे साहब को बोल दे इसे ताला मार दे इधर से ताला मार। हाँ, और शिवे साहब को बोल दे कि मैं इधर से निकलूंगा। ठीक है। So if there is no question, we continue. Now, you see, nutrients are having three different forms depending upon their speed of availability. So, readily means quickly available, moderately available, or slowly available nutrients. So, let us find the difference in all these three. Absorption of nutrients depend upon their forms. In what form they are there. So, absorption will be dependent. For example, most plants prefer nitrate nitrogen over ammonical nitrogen, except rice. Rice prefers ammonical nitrogen. Or maybe some other aquatic plants, they prefer ammonical nitrogen. It is by nature. Take the case of iron. If you have choice, ferric or ferrous. So most of the iron in rice is taken up in ferrous form, and other aerobic plants, some aerobic plants, they prefer ferric form. Similarly, in case of phosphorus, you go two forms, H2PO4 and HPO4, monoorthophosphate and this divalent. So in this case, monoorthophosphate, H2PO4 is preferred form over HPO4 by most of the plant. So you can see absorption of nutrients depend upon their forms. So if one particular form is available in sufficient supply, then the uptake will be more. So phosphorus especially available as H2PO4 and HPO4, but unavailable rapidly in tricalcium phosphate or apatite forms. So phosphorus is not absorbed in tricalcium phosphate, it gets fixed. So it is kind of partly insoluble mineral, tricalcium phosphate, which can further be converted into apatite. Nutrients in soil solution are readily available. So whatsoever nutrients are there in soil solution, they are part of the rapidly available nutrients. So whatever H2PO4 is there, it is in soil solution. You will never find phosphate power 3. Nutrients on exchange complex are also available for absorption, but not quite as readily available as from the soil solution. So therefore, you already understand that plants take up most of the nutrients from the soil solution. But however, if you remember, there may be some contact exchange. So sometimes these roots can reach the exchange sites, or they can access the colloids and they can exchange the nutrients there. So nutrients on exchange complex are also available for absorption, but not quite as readily available as from the soil solution. Now you see, this is very important slide. You try to understand it. Relative availability of different forms of inorganic phosphorus to plants. So you can see this table. Inorganic phosphorus in soil. First one is mineral phosphorus and very strongly adsorbed phosphorus. This is adsorbed phosphorus. Calcium, iron, aluminum phosphate, minerals, and very strongly adsorbed phosphate. So these are the forms. These are adsorbed form, and then they are in mineral form. Aluminum phosphate or calcium phosphate or iron phosphate. So they are precipitated, they are not in soluble forms, and they have come from available phosphorus actually, but they got fixed under acidic or basic conditions. So you see, availability to plant is very, very low in this case, which has been precipitated. Number two is strongly adsorbed P. The first one was either mineral P or very strongly adsorbed P. These are four different forms of phosphorus in soil. First is mineral P or very strongly adsorbed P. This is in minerals or precipitated, which is very low availability. Number two is strongly adsorbed P. P adsorbed to clay and other mineral surfaces. So this is of low availability. Third one is weakly adsorbed. This is weakly adsorbed. P adsorbed to clay and other mineral surfaces. So then it is your high availability. Here you got high availability. And finally, whatever solution P is there, the availability is high. And in solution P, forms are H2PO4 and HPO4. What is the soil pH at which both these forms have equal proportion, H2PO4 and HPO4? Any student?
7.2.
Correct. It is 7.3, at which we get almost equal concentration of H2PO4 and PO4, HPO4. Now, cycling of nutrients in the soil. So it is better to leave this and join on the link 3, okay? Please join at the link 3. Okay, everybody listening?
Yes, sir.
Okay,
sir.
Yeah.
Good, sir.
okay. So just now you have seen different forms of phosphorus availability from very low to high. Now, see, cycling of nutrients in the soil means what are different sources, how it is coming and how it is going back, going outside. So plant uptake reduces the amount of nutrients in the soil solution. It is very clear. Nutrients adsorbed on minerals or humus get dissolved and enter the soil solution, because solution will get nutrients from the minerals or it can get from exchangeable site. Whatever sources of nutrients are there, those sources will add nutrients to the soil solution. Minerals in soil dissolve to buffer the soil solution. Soil organic matter also go under for decomposition and supply the nutrients to the soil solution. Microbes, first they absorb the nutrients from soil solution and then they decompose after their death, and then they give or release nutrients into soil solution. This is interested point, new point for you, that there may be some biological nitrogen fixation from the soil and certain nitrogen may leak from the root nodules and it can be part of the soil solution. And some of you might be knowing that almost 50% nitrogen is given to the soil or to the associated plants by the legume crops in one season, cultivated legumes or annual legumes. Nutrients are removed by crop harvest. You have crop uptake, you can say. Large fractions of certain nutrients lost by erosion, leaching, runoff, water utilization. So this is how we can lose nutrients from the soil solution by different mechanisms. Now, we are coming to the main part of this lecture, which is factor affecting the supply of mineral nutrients, or other way around, if I ask you, what are the factors that affect the nutrient availability? It can be both ways. What are the factors that affect the nutrient availability? This is one. Other could be, what are the factors that influence the supply of mineral nutrients to the soil solution? Here, soil solution will be hidden. You can be asked that suggest the factors that affect the supply of mineral nutrients. That will be your question. Nobody will write to the soil solution, but you can remember that it is soil solution is hidden, because nutrients are to be taken up by plants from the soil solution, or otherwise it can be factors affecting nutrient availability. There are a large number of factors, but these 7 are most important one. So we'll discuss one by one and hope we can complete at least 2-3 factors today, and remaining factors I will finish today. So tomorrow, I'm sorry, tomorrow. So are you ready for tomorrow's class at 5 p.m. or you want to change the time or you want to cancel the class? You have the choice. 3 choices are there. One choice, class at 5 p.m. Fine. Another choice, cancel the class totally. Third choice is we can change the time. So ABC. You can tell me. Shambhavi, are you there? Shambhavi,
Yes, sir.
what is your take? कोई
Sir,
जबरदस्त
I'll discuss with my friends.
Okay.
Because on Sunday, sir, we have exam of NABARD.
Sunday. So
Yeah.
Sunday cancelled. Sunday cancelled. If you have exam, we can cancel it. Sunday we can cancel it. What about tomorrow? Saturday.
So it is fine for me.
Saturday is fine for you. And
Yes, sir.
Sunday? Sunday?
No, sir. Sunday I have exam.
Okay. Only one student has exam or others also have exam? Because next week I think you will go for your examination. Is it correct?
Yes, sir.
Hello? So even if one is absent, it won't matter much because I am recording these lectures. So those who miss the class can use recordings also. So that way you can compensate somebody. If others agree.
Sure, sir.
Okay. So Abdul,
यस सर
oh,
रूम में सर
room. Do you agree for tomorrow's class?
यस सर
5 p.m. is fine.
यस सर फाइन इज फाइन
Raghavendra? Hello? Raghavendra? Manisha?
Hello, sir.
Manisha,
Yes, sir.
are you there?
Yes, sir.
Okay, is it fine for tomorrow?
Yes, sir.
Yes,
sir.
So I'll take at 5 p.m. Okay. So now we come back to the topic, these factors affecting nutrient availability, mobility of nutrients in soil. So we can discuss how the mobility of nutrient in soil means how the nutrients will reach the soil solution, how fast they can reach. Naturally, the distribution of nutrients in the soil will be different for different nutrients, depending upon the mobility of the nutrients. If a nutrient is mobile, very fast mobile, then it will be uniformly distributed in the soil. Uniformly distribution can be there because such knowledge will help us to design or devise the methods of nutrient application, the method of fertilizer application. Therefore, to understand mobility of nutrient is very, very important because this will help us in deciding the method of fertilizer application. For example, if we know that a nutrient is less mobile in the soil, then what method will be good for application? Anyone? If a nutrient is mobile in the soil or immobile, suppose immobile in soil, what method of application would be the best?
सर foliar application
Foliar application is last resort actually. I'm speaking about method of fertilizer application, or you can say method of fertilizer application in soil. Okay, so foliar application is fine, it's fine, but we should know that what are the nutrients that are applied through foliar nutrition. So through foliar nutrition, we supply nitrogen, we supply phosphorus, and sometimes we supply micronutrients. But that is not the major method of fertilizer application. That is very minor method of fertilizer or nutrient application, which is used in, or I can say, which is not a practice, I can say straightway, which is just in case of exigency or emergency, farmers use foliar application. Otherwise, the major method of fertilizer application is directly into the soil. So tell me, which method of fertilizer application is recommended for immobile nutrient into the soil? Hello? Hello, Abdul.
yes sir
Which method? यार कितने मेथड है? How many method are there for fertilizer application? How many methods are there? Hardly 2-3 methods are there. One is broadcast,
sir.
other is placement.
Broadcasting, yes, sir.
Broadcast and placement. These are two important
Yes, sir.
methods. In broadcasting, I'm sorry, friends, just for 1 minute, give me a minute. I'm getting some very urgent call, which I don't want to miss. Dear student, I'm sorry, I'll miss this class now. And I got some urgent call from the office. So see you tomorrow, okay? Is it fine?
Okay, sir.
Okay,
Yes, sir.
I leave the meeting here, yeah. I'll answer your questions tomorrow.